For parallel lines and perpendicular lines, we recall that the slope of any line segment within a line represents the slope of the line. Consider then two lines with slopes of M1, or slope 1, and slope 2. The lines are going to be parallel if M1 is equal to M2. The lines are perpendicular if the product of M1 and M2 is -1. Or, for perpendicular lines, each slope is the negative reciprocal of the other, provided neither of them is equal to 0. So, if we put that into practice, if we consider line segment AC with a slope of 3/4, write the slope of line segment GH, which is parallel to AC. Well, the slope of GH, if it's parallel, is just going to also equal 3/4. If line BF is perpendicular to AC, then the slope of BF is going to equal, well, the original one was positive, so this one has to be negative. And then I take the numerator and denominator and flip them, so I'm going to wind up with 4/3. If I am determining if the lines are parallel, perpendicular, or neither, then in the first case, I have 1/4 and 3/12. Well, 3/12, I can reduce that fraction to 1/4, dividing the top and the bottom by 3, and these ones are parallel. They both have equivalent slopes. In the second case, I have 5/7 and 14/10. Well, 14/10 can get reduced down to 7/5, but they're both positive. So even though the reciprocals are both positive, so the sign didn't change, which means that these are neither. If it happened to be -7/5, it would have been perpendicular, but because it's not, it is neither parallel nor perpendicular. If P is the point 4, 7, and Q is the point 6 and -2, find the slope of a line segment parallel to PQ. Well, I'm just finding the slope of a line segment that's going to match PQ. So in this case, I'm just going to solve for what the slope is. And I'm going to say the slope is going to be equal to, put the y value for P on the top, x value for P on the bottom, and then subtract from that the y value from Q and the x value from Q. And I can say that this is going to wind up being 9/-2. So the slope I'm looking for that is parallel is going to equal 9/-2. In the second case, I would start the same way. If I want to solve for a perpendicular line, I would find the slope of my original line, 7 minus -2 over 4 minus 6, and get 9/-2. The perpendicular slope, and this is a little sign that we use for perpendicular, is going to equal, well, the original one was negative, so the new one has to be positive. And if it was 9/2, it's going to become +2/9. If triangle LMN has coordinates at -4 and 2, -2 and 7, or 1 and 0, use slopes to show that it is right-angled at the point of L. Well, if it's right-angled at L, then it means that it has to be perpendicular at L or create a 90-degree angle at L. So in this case, I need to show that the slope of L to M and the slope of L to N, because remember, it's both connecting from L, have to be perpendicular to each other. So for L to M, I'm going to say that I have 2 minus 7 on the top, and I have -4 minus -2 on the bottom. And that is going to give me -5 over -2, or just 5 over 2. For Ln, I'm going to state that I have 2 minus 0 on the top and -4 minus 1 on the bottom. 2 minus 0 is going to give me 2, and -4 minus 1 is going to give me -5. And then I can say that 5 over 2 is perpendicular to -2 over 5, which means that it is a right angle triangle at L. Alright, the last part, which is most complicated. Two lines have slopes of -3 over 4 and k over 5 respectively. What is the value of k if the lines are parallel? Well, if they're parallel, then that means that they have to be equivalent. So if one is -3 over 4, then the second one has to be equal to it, which would give me k over 5. To solve for k, I'm going to cross multiply. I'm going to take that -3 times 5 divided by 4, or -15 over 4. If they are perpendicular, then I'm going to take the negative reciprocal of the one that I know and say that it's going to be 4 over 3 is equal to what my new line is, k over 5. And then I'm going to do the same process. I'm going to cross multiply, and k is going to be 4 times 5 divided by 3, or 20 over 3. And there's my solution.